Hi friends, in this lecture I am going to discuss problems. Let us see first one. A block of mass 1 kg slides down a curved track that is one quadrant of a circle of radius 1 meter. Its speed at the bottom is 2 meter per second. The work done by frictional force is, see what is given. It slides down a curved track. It is one quadrant of a circle of radius 1 meter. Okay, given speed at the bottom, that is 2 meter per second. So work done by frictional force is, see how to start. It is now given one quadrant. Let us like this one quadrant. Radius is given 1 meter. And coming to velocity. See velocity given how much? Velocity at the bottom is given 2 meter per second. At the bottom, velocity 2 meter per second. Okay, right. See, when we release the body from this position, if it is released from this position, if there is no friction, when it reaches the bottom, its velocity must be equal to, or I can say, using energy conservation, there's a corresponding height is equal to R. So loss in the potential energy means mgh. This loss converts into kinetic energy. That means half mv square. Okay. But now in this case, because of friction, that energy is lost, means some part of the energy is lost. So here what we can do is, we are expecting that it should be m g h value 1. So we expect that at the bottom, kinetic energy must be equal to 10 joule. Okay. Now see what is the kinetic energy. So kinetic energy is equal to, this is the initial potential energy, you can say. Okay. Kinetic energy equal to half mv square. That is now 2 joule. If there is no friction, this potential energy completely converts into kinetic energy. That is 10 joule. Now only 2 is available. So how much energy is lost? That is 8 joules of energy is lost. So by friction, work done, that is equal to minus 8 joule. Because by friction, negative work is done. That's why energy is lost. Okay. Let us see next one. An object is attached to a vertical unstretched light spring suspended from a ceiling and slowly lowered to its equilibrium position. This stretches the spring by x. If the same object is attached to the same vertical spring but permitted to fall suddenly, the spring stretches by. Okay, let us see. So first note down the given data. There is a ceiling. A spring attached to the ceiling, and to the other end, a block is attached. So first condition, it is given that slowly lowered. Assume that you are keeping your hand below the block. Now slowly move the hand. Then it stretches by x. That means we can say net force equal to 0 because slowly given elongation is x. That means its weight mg is balanced by spring force, that is a kx. Okay. Now given second case, it is allowed to fall suddenly. Then see what happens. When it is allowed to fall suddenly, when it reaches this position where net force is 0, it is having velocity. Get the point. So here we are moving it very slowly. Very slowly means velocity almost 0. So when you are leaving here, what happens is it will be at rest permanently. This is equilibrium position. Okay. But coming to here, what we are doing is you can assume like we are keeping the hand below the block. Now remove the hand suddenly. So when it is reaching this position, net force equal to 0, kx and mg. But it has velocity. Because of that velocity, it continues to move down until velocity becomes 0 temporarily. That means somewhere here it will come to rest temporarily. Okay. Now this value how much? So take it as y. Okay. So you can see initially it was at rest. Now also it is at rest. That means initially no kinetic energy and finally also no kinetic energy. Means delta K is 0. That's why I am using here work energy theorem. Net work is equal to delta K. Okay. Then see what happens. Because of gravitational force work done, m into g into y. It is a positive. Because gravitational force is downwards and displacement also downwards. But coming to by spring force is upwards because when it is moving down, it is elongating. Spring force is upwards, but displacement is downwards. Therefore, by spring force, negative work is done. So that's why minus here half ky square. That is equal to 0. From this, y equal to 2mg by k. And here we got kx equal to mg. Kx equal to mg. From that x equal to mg upon k. That means now this is a 2 times of that value. Okay. Or same thing we can write instead of taking work energy theorem. Loss in the gravitational potential energy converts into spring potential energy. If you are taking spring, block and earth as a system, then you can write loss in gravitational potential energy is converting into gain in the spring potential energy. That is a half ky square without writing work energy theorem. Then from here once again y equal to 2mg by k. Either we can solve in this way or we can solve like this also. Okay. Let us see next one. A block of mass m is attached with a spring in its natural length of spring constant k. The other end A of the spring is moved with a constant acceleration A away from the block as shown in the figure. Find the maximum extension in the spring. Assume that initially block and spring are at rest with respect to ground frame. And you can see this question almost same as the previous problem. There we got maximum elongation is 2 mg by k. The only change is in the place of g, it is now a. Okay, let us see once. It is given that a block of mass m spring, and for this point there is a constant acceleration a. Okay, if you observe carefully with respect to this point, with respect to that point, that means we are solving question from a non-inertial frame. Okay, then see what happens. If you are solving with respect to that point is having constant acceleration. With respect to that point, this point is now fixed. Why fixed means we are solving with respect to this point. Therefore, that point is stationary. Then on this force, pseudo force acts, which is m a, and it is a constant. Okay. Then again, I can write here because of pseudo force, it is having elongation. Suppose elongates by a distance y. Okay. Then use work energy theorem. Same as a previous problem. Initially, it was at rest, k value 0. Finally, comes to rest temporarily, again k value 0. So delta k value 0. Okay. So by pseudo force work done, is a constant force directly m into a into y. By spring force, negative work is done because when block moves left side, spring force is right side. So minus half ky square equal to 0. From this y equal to 2ma by so only changes in the place of a, it is acceleration, right? That is g. So in the last question, we got 2mg by k. It is now 2ma by k. So both are almost same problem, right? Let us see next one. Let's see the question given. Referring the graphs, choose wrong statement. Focus carefully. First one, force versus position. Second one, potential energy versus position. Okay. Now see what happens here. The particle has stable equilibrium at points 3 and B. B, we can see at B, potential energy is minimum. So it is stable. That is clear. Coming to 3. Now see carefully. If you are slightly displacing right side, okay, you can see at 3, net force 0, right? That is clear. If you slightly displace right side, force will be negative. See carefully. Right side of point 3, F is negative. So if you displace right side, force will be left side. Negative means. If you displace left of point 3, force is positive. That means the force is right side. That means a restoring force is developed when we displace from position 3. That means 3 corresponds to stable equilibrium. So option A is correct one. But he's asking wrong statement. Okay. Let us see option B. The particle is in neutral equilibrium at a point B and 2. B, neutral equilibrium. That is wrong. Just now we discussed. It is a stable equilibrium. Coming to 2. This is not equilibrium because force is not zero, right? If net force 0, that is equilibrium. And we can see corresponding to 2. Net force is not 0, right? So option B is wrong. Next, no power is delivered by the force on the particle at the points 1, 3 and B. So power delivered F bar dot B bar, right? We can set 1, force 0. Therefore, no power is delivered because F bar dot V bar, no force means no power. 3, again no force, so no power. Coming to B, this is a stable equilibrium. That means here also net force how much? 0. So C is a correct option. Okay. Next, particle has unstable equilibrium at point 1. See carefully at 1. Net force 0. If you displace to right side, force positive. That means if you displace right side, force also right side. If you displace left side, force negative. That means if you displace left side, force also negative, which indicates it is unstable equilibrium. So D is the correct one. Okay. That means the only wrong statement is B. Okay. Let us see next one. A simple pendulum is oscillating with an angular amplitude of 90. For what values of theta with vertical, the acceleration is directed vertically upwards, horizontal, vertically downwards. Let us see. Right. Condition given that simple pendulum with an angular amplitude 9. Simple pendulum and given angular amplitude is 90. That means string becomes a horizontal, comes to rest, moves back like this, and again comes to rest, and again moves back like this. Okay. And for what values of theta given? For what values of theta with vertical? Let us see now. For what values of theta with vertical? It is now following the circular path like this. Now suppose this is angle theta. First we can verify options vertically upward or vertically downwards. Acceleration equal to net force by mass, right? If you observe, when string becomes horizontal, no tension, right? Because velocity is zero. Velocity is zero, so here no tension. That means when string becomes horizontal, net force is mg, which is downwards. That means acceleration is vertically downwards. Theta equal to 90. You can see which option matching like that. Vertically downwards. Option A matching for 90 and option B matching. Okay, these two are matching. Next, verify vertically upwards. You can see when string becomes vertical, when string is vertical, mg downwards and tension upwards. And we can see tension minus mg. Tension minus mg. That is now net force, which we are calling as centripetal force. Okay, tension towards center, mg downwards. So T minus mg, that is now centripetal force towards the center, means upwards. That means when theta equal to 0, acceleration is vertically upwards. So option A is matching, right? Let us see now when it becomes a horizontal. Okay, so when it becomes a horizontal, suppose when it makes angle theta, it makes angle theta at this instant, you can focus centripetal acceleration towards the center, that is AC. Tangential acceleration, that is along the tangent, right? Resultant of these two should be horizontal, that is A. Okay. Now we can see in this, you can see angle made by resultant acceleration with a tangential acceleration. This angle also equal to theta, right? Now we can write tan theta equal to AC upon AT, because AC and AT are two vectors which are mutually perpendicular. Okay, one is towards the center and one is along tangent. And A is now resultant of these two. Then angle made by resultant with a tangential acceleration, that is AC by AT. And we are knowing that, so if you draw free body diagram at that instant, at that instant, you can see mg vertically downwards. Its a component is now along a tangent. If this is a theta, it is mg sine theta, right? That means the tangential acceleration is g sine theta, because tangential force is now mg sine theta. Therefore, tangential acceleration is g sine theta. So AT value is known. Now we have to focus how to get centripetal acceleration. Centripetal acceleration is v square upon r, right? And AT value g sine theta. So to find v square by r, or to find v square, I am using conservation of mechanical energy. Let us say releasing from here. When it makes angle theta, you can see by what distance it has come down. It has come down by a distance r cos theta. See carefully. It was initially vertical like this. Now it is here. How much a height? It has come down along vertical. It is r cos theta. That means loss in gravitational potential energy is mg r cos theta. This is loss in gravitational potential energy. This converts into kinetic energy of mv square. Okay. So from this we are going to get v square value, or directly can find v square by r, because we want AC, right? V square by r, mass gets cancelled. From this I can get v square upon r. How much? It is 2g cos theta. That is AC. Now remind just simplification. Tan theta equal to, it is equal to AC. In the place of AC, 2g cos theta upon, in the place of AT, it is g sine theta. G cancels. It is now 2 cot theta. Or from this we can say tan theta equal to root, right? Because cot is 1 by tan square equal to 2, tan equal to root 2. Now options given in terms of cos. Okay. Tan value root 2 means cos value. It is 1 upon root 3, right? because tan means you can see here tan theta root 2 by 1. Then cos value how much? It is 1 by root. That means when angle is a cos inverse 1 by root 3, acceleration will be horizontal. Okay, let us see next one. A block of mass 5 kg is dropped onto a massless pan attached to a spring of constant 200 Newton per meter from a height h. The second end of the spring is attached to a second block of mass 10 kg as shown. The minimum value of h so that the block M bounces off the ground if the block M sticks to the pan immediately after it comes in contact with it is. Okay, then see how to solve it. Right. See first of all the given data. This is small m. This is now spring attached to capital M. And this height that is equal to h, given this is a 10 kg, k value 200 Newton per meter, and this is a 5 kg. Okay, condition given that it sticks to the pan immediately. Okay, right. First of all, we have to focus condition for 10 kg block to bounce off the ground. So it will lose contact with the ground if spring force is greater than mg, and direction of spring force must be upwards. Okay, so spring force must be upwards. That happens if the spring is having elongation. So kx and this is mg. Okay, and you know k value given 200. Okay, so 200, this is 100. That means x value half, 0.5 meter. Assume that Hooke's law is valid. Okay, right. That means see here exactly what happens when it sticks to this one. First spring will be compressed. Okay, it will compress. Then block will come to rest temporarily and again moves back. So while moving back, what happens is it will elongate. Okay, so when elongation is 0.5, then it is about to lose contact. So now we are taking condition that when it is about to lose contact, this block will come to rest temporarily because we have to find H minimum. Its minimum value how much? So minimum means when this is about to lose contact, it will come to rest temporarily. Okay. Then say what I'm writing here. Writing energy equation because there is no loss of energy. So it has come down by what distance? Let us say gravitational potential energy lost. It is mg into, see the equation carefully. For example, so here one thing is that h must be definitely greater than x. Okay. So when it comes to rest temporarily after moving a distance of 0.5. Okay, that means this block has lost gravitational potential energy that is given by mg into h minus x. Okay, this is a distance that it has come down. Next, this loss in gravitational potential energy is converting into gain in the spring potential energy. That is half k x square. Okay, I am repeating here. See carefully. H must be greater than x. That is clear. Now it has come down by what distance? H minus x. This loss in gravitational potential energy converting into gain in the spring potential energy. Okay. Remain just calculation part. Put values in this. M value 5. G 10. H we have to calculate. This x value half. Next K 200 and this is 2. So this becomes 100 x square. That becomes 25 10 power minus 2. Okay. See the calculation. 10 power minus 2 and 2 zeros are cancels. Next 25. 25 here how many times? 5 times 50, 2 times. Okay. 2 times. So 2h minus 1 equal to 1. That means 2h equal to 2. That implies h value is 1 meter. Okay. So it is just a focusing energy equation. And next, force equation. It is just losing contact with the ground. So I hope you got the clarity. So answer is now option A, right? 1 meter.